fucking censor that, I need lol.
Uh, let's see. Okay, I think we can start. So today's topic is encapsulation is abstraction. Uh, the purpose of this lesson is to explain the difference between the two and to delve deeper into what actually is encapsulation, as the term is oftenly used interchangeably with abstraction. And this is a supplementary lesson to the previous lesson, which was about classes, which focuses more how to write neat classes, proper classes, classes which are usable, and classes which are intuitive to use. So let's get right to it. What is encapsulation? First of all, it's a technique. It's a technique which hides internals of a class, exposing it through methods. What does that mean? Well, in C#, we have, well, in all OP languages, we have properties, methods which tell how we set or get fields of a class. And the purpose of properties is to hide internals. And for that reason, we don't expose our fields as public, and we use properties to expose what we want. So shallow encapsulation in C# is done through properties, where instead of writing public fields, you simply write public properties. And another part of encapsulation is bundling together data and methods into a single class. So data plus methods makes up class. Instances of classes are objects, and the class itself you could call a byproduct, a direct product of encapsulation, because encapsulation, like a capsule, wraps and bundles together the concept that you need, basically, the business logic that you need, the related, tightly related logic into a single thing, a single entity. And what is abstraction? Abstraction, on second thought, is a concept. All it means is basically removing unnecessary details. So in other words, we expose the very minimal that we need, the highest level functions that we need to use, functions that are obvious to use, functions that are meant not for sheer functionality of our class, but more of an abstraction, a readable expression, an easy to understand abstraction for us humans. For example, if you have a clock, you don't care about anything except time. Also, you should care about turning the clock on and off. That's all the clock has public to us. Time, on and off. It might have a timer, it might have other things, but essentially that's what a clock is. We don't publicly control daytime, which is right now. We don't publicly control the tick speed and many other things. Another example would be when we withdraw or put funds in our bank account, we simply press a button which does a bunch of stuff which is hidden from us. We know what it does in a nutshell, but we don't really understand what happens under the hood, and we don't really have to. And that's the key concept of abstraction. Just understanding stuff in a black box is enough in order to call the functionality that we want. Nothing else is needed. So, with that being said, we use encapsulation to implement abstraction, because encapsulation hides stuff that we don't need, and it wraps objects, different data and methods into one entity, and that entity is an abstraction of our business logic. So it is an abstraction in some way. It is, though, an incomplete abstraction, because it means that we bundle stuff together and we give it a name. That's all we do. We wrap them and use it as one. That's all we do. We hide something. That's all we do in encapsulation, but that's still not complete abstraction. It's still missing something. So abstraction, even though encapsulation is abstraction, abstraction is not encapsulation. Encapsulation is simply an implementation of a concept called abstraction. What abstraction does more than encapsulation, we use different things through which we abstract our stuff away. And we abstract different things. Encapsulation is sheerly related to classes. Classes and its internals. That's what we encapsulate. But abstraction is a relation between classes, it's relation between projects, and that's why the definition expands to internal classes, where we abstract our projects away from other projects in solution, where we don't show all the classes that we have in the project to other classes. So it's much easier to find the relevant stuff, the main stuff that the author of your program or program wanted to show. Let's see, Twitch, if no questions. Hello, Dark Sam. Okay. So that's the purpose of abstraction. It's to abstract away details that you don't need. So internal classes abstract away details in the solution scope. Interfaces abstract details away when classes, when you use a class which is interfaced, you have behavior, a strictly defined behavior through an interface, and that's all. So you no longer, you might have properties to an interface, but all you have essentially is a bunch of methods. In an abstract class, you have a parent class, just like in inheritance, except that that class cannot be created, and that class needs some methods to be implemented in the child classes. But essentially, the three abstract class, inheritance, and interfaces are an example of polymorphism, which is an example of abstraction, more like implementation of abstraction. So combining the three, which is encapsulation, abstraction, and internal access modifiers, you can create a full, beautiful, complete implementation of abstraction. So now let's go to examples. And I would first like to create a shallow example of what a not so beautiful class would look like. So let's say you have to design a library which will later on be used in a spellcasting game. So you need a spell, a caster. So basically you need a caster which casts spells. So let's start with a spell, some entity. A spell should have a description, a name, and a mana cost. And mana cost. Now, the first thing, which not many people do these days because we have properties, I wrote public fields. I think public fields should not exist, only in very special cases. The only case where I consider a public field being reasonably useful is when you want slightly less code and when you have method syntax accepting references. In those cases, having field, the public field, is not so terrible, though of course it could be avoided. So I will do an example for that. Let's say you have a sample method which takes an integer by reference. Right. Void test. Static. That is static 2. So now we have a number and we don't do anything, that's just an example. Here we create a spell, var spell. Spell is new spell. And in test, let's say we would like to put a number to that spell. So to the test method. So if I say spell dot mana, as a reference, it works. But if I use this as a property, it doesn't work, saying that it returns temporary value. Keep in mind that this is not data, this is a method. It is a mini proxy which essentially accesses underscore private int underscore mana. That's what the get does, and this itself cannot be passed by a reference. So sometimes sometimes it's really inconvenient. It would be really tedious to write this as a variable like that, and then passing that instead, and then setting that after the result is just an ugly way of going around it. So in some cases it's okay, but ref itself is not the best practice. There are better ways how you can use it. So it's just a workaround to an already potential code smell caused by bad, poor code design. So in this case, you could write that. That's just a minor detail which I stumbled across when developing, but in decent, normal, good solutions, you won't really see that. Okay. So I will keep this as that, and I will still... Okay, I don't need this anymore. Okay. Now, when you think about spell, you should think how much will it change. And in this case, will the spell change after being created? Right now, the design would be that we set every property separately after creating, and potentially a spell without a name or mana cost can exist. But is that really true? And the answer is most likely not. So a part of abstraction is telling what a spell is made of, the very minimum that the spell should have. So by putting the very minimum in constructor, you can work on it. So the very minimum is name and mana cost. So now your spell has a name and it has a mana cost. Now a spell can exist. So now when I create a spell, I need to provide it to fireball costs 10. And potentially you can have a description, big AoE. That's a spell. And our constructor defines what the spell needs to have. You might say that the description of a spell is made of all of this. The three things make a description. So we could have a private string underscore description, and this description would not have a setter anymore. It would have a getter, which essentially concatenates the four. So it says that name name, mana, and description. Underscore description. And it returns this. So that's our property for description. So when we set the description, when we set the description, we set that description only. Like as a side note to what the full spell actually is. And this is a bit flunky implementation of it, but like this, we can override the string by simply returning the description. So that's our implementation of a spell, and you might think this is a good spell, but first mistakes. You have a setter. That means that potentially upon creating a spell, you might change its name. Is that really true? No. I don't really think that mana will change as well, so it should be deleted too. And last but not least, description. Well, it will probably have a setter too, so that's fine. So lastly, the public class. Spell should be a public class. And now we should think, how are we supposed to use a spell? What does it do? What does a spell do? We cast a spell, and we usually have a target for our spells. So it's a complex situation, but a spell has a target. And it might have an output. For example, if I use a spell, I might create a wall. I might influence environment in some way. I might create fire, spawn something, and stuff like that. So spell should have some means to apply its effect to some target. So I should have a bunch of targets. But for this tutorial, I'll stick to an easy spell, which is damage spell. And damage or healing or buffing spell. Yep. Damage, healing, or buffing spell. Not some environmental spell, because it would be beyond complexity assessment. So we have target. Let's create the interface. The point of this is to have a target, some sort of target, which accepts effect of a spell. So we feed spell effect to a target. To a target. I target effects. I spell effect. Oh crap. Don't reference that. Create spell effect. And what spell effect does, it will have value. Well, the thing about spell effects is a tricky one, because a spell can be a fireball which heals allies, buffs them and damages enemies. And it's AoE. Mind popped, because it's really hard to compose a spell like that. And for this tutorial, for this lesson, I'll stick to a simple damage spell. So a spell applies damage to a target, and this target will simply have HP. A property, HP, hit points, yeah, hit points. Sorry, it won't have hit points, but it will have apply method. Apply, receive effect. That's what I meant. Receive, I spell, just spell. I spell. And that's it. And it should have HP. Yeah, it should have HP. So float HP get. Let's create a spell, and it will have float damage get. Damage spell for now, right? And spell receives I damage spell. Okay, just spell. We won't be using damage for now. Okay, so now our target receives this, and our spell, damage spell, I'll actually name it damage spell, will do some damage too. So name, mana, description, and damage, which will also be immutable. Right. And the constructor, it does some damage. Damage spell. Damage spell, damage spell. Right. So now we apply our spell to some target. We apply effects of the spell to a target. And what it does, well, let's change that to just target. Call it a class. Okay, never mind, don't change it to target. We will give an implementation. So enemy 1 is implements iTarget. It's a class, and some sort of HP. All I care about. So let's implement those. HP, we set HP, and our HP is in here. And receive, all it does is HP minus equal spell damage. So now we have an option of writing get, which we have to, but at the same time it should be private. Sorry, set. Private set. Because we don't want to change HP outside, we want to encapsulate it. So an even better way of doing this would be through another method which encapsulates the fact of taking damage itself. So taking damage means subtracting some value from your hit points, and this is what an enemy should be able to handle. So handling taking damage and receiving a spell effect is something that we want. We could, of course, make this more elegant. We could do this, spell damage, and damageable. I thought of simply saying take damage on target, because that's all the target would have, but maybe next time. It's okay in this case, in this sense. Whoops. Let's fix this. Oh crap. Damage spell. Okay. Damage spell, damage 5. Let's see. Now we have a damage spell, we have a target, and we have an enemy implementation of a target. An example class. Last thing we need is a caster. Someone who could actually cast spells and hold spells. So, caster. Should have a name. And should have also a... that's it. Just the name. How do we access spells? A caster needs a way to access spells. A caster accesses spells through a spellbook. So, let's say a dictionary of spells. So by name, we get back a spell. Those are our spells. Hello, Decker. Now we create spells. Really? Echo? Really? Oh my god. Oh my god. It's horrible. Is it any better? I wonder. Is it any better? I wonder. Nope. Is it any better? I wonder. Nope. Is it any better? I wonder. Nope. Okay. Uh, I think I will get a new mic for the next time. That's the solution. And yes, I am. That's a sign, the first step to insanity. Okay. Anyways, let's wrap this up. So we have a caster class, and a caster should be able to cast a spell by name. It's pretty bad, but okay. I really plan to buy a microphone, but the one I want is not available yet. I might consider buying from AliExpress. I hope I will find what I want. So we get our spell from the spells dictionary, and when we cast, we select a target. We cast a spell. We select a target. And we say target, apply, receive, spell. So spell. Spell. Spell name, more like. Spell. Naming. Name of a spell. And that's it. So the thing is, having spells as public is completely useless in this case, because we want it encapsulated. We don't want to expose spells as such. Also, another thing, spells, we need a way to add a spell. We could write void, public void add spell method, which adds a spell to our dictionary. But the whole thing about this is that it's not abstract. Right now, we literally know that we're adding a spell to a collection, and that's just not natural. It feels artificial. So how does a caster add a new spell? A caster doesn't add new spells, a caster learns new spells. So that's a much better way of doing it. And another thing that bothers me is that spell is not just a dictionary of like, this is a spell book essentially. So a much better name is a spell book. And a spell book is not just a dictionary of spells. It's more to it than just that. It should be abstracted away. So a spell book should be an actual class. Let's create a spell book. And hell no, I don't want to inherit a dictionary. So spellbook inside of itself will have a dictionary. And I want to do this in a constructor. So public spellbook spellbook is this. And what this gives me now, it gives me an ability to add a spell. damage spell. And it also gives me some more things, but first let's do that. Add spell by name, and a spellbook should have slots. So when I create a spellbook, I should assign a certain number of slots that it has. And actually, I should support adding many spells at once, in case I want that. So that is a good point. Was about to, and so now I can do for each var spell and spells. And the thing about adding a spell, if my var needed slots is spellbook count plus spells that I want to add length array. So that's the amount of slots I need, and if my maximum slots is less than needed slots, that means I should throw an error. So the spellbook out of slots exception is my error. Create exception. And the error essentially is spellbook exception is too vague. I like very specific ones. So public spellbook out of slots exception takes in slots, needed slots, and actual slots. And I'll do quick renaming. Slots, actual, actually no needed slots, actual slots. And base, the message will be needed slots, available actual slots, missing actual slots, needed slots minus actual slots. Okay. So now I feed needed and slots, and it'll give me a nice error message. Otherwise, I add each spell to the spellbook. Also, I should handle, well, now that I have a way of handling it here, when I create a spellbook, I should optionally have params of spells that I want to initially populate my spellbook with. So damage spell, which can be 0 to many. And I add them through the method that I just made so that I don't rewrite functionality. Alright, and this is our spellbook. Of course, for perfect sense, it makes perfect sense to interface it as the class is public. and it has functionality. Yep. So the purpose of iSpellbook. The purpose of this whole thing that I just did is add spell. So the purpose of this whole thing that I just did is that right now we don't treat spellbook as just a dictionary. We treat it as an entity, as business entity. And for example, we don't want to be able to directly remove elements from the spellbook as it's not supported. But with dictionary, there is no way to do that. We can only make dictionary read-only, but that doesn't prevent us from removing elements from it. Yet with a spellbook, we can. With a spellbook, we can achieve just the right behavior that we want. And thanks for the tip. Extract interface. Didn't know that was a thing. Right click, extract interface. Extract interface. Refactor. Extract interface. Nice. Why was this not interfaced then, I wonder? Oh, really? Refactor, extract, interface. Ah, okay. Thanks, really nice. Okay. Slots, right. Okay, that's really cool. So now we have a spellbook. We want to get an element from a spellbook. Is indexer supported for interface? I never wrote it. This string. Really? Holy shit, that's so cool. Name. Fuck. I want spell. This spell. I'm making probably spelling mistake. This spell string name get. What am I missing? What am I missing? Let me get. Okay, let me try indexer from spellbook directly, as I will do it anyways. Oh right, I just tried non-implemented one. Type missing. Type is spell. Oh, first type, then indexer. Damage spell. Oh, right. Get only. Okay, very nice. Makes sense. Okay, so my get, I want to access directly the spellbook. Yes. I totally agree. Return spells. this is not spellbook anymore, but just spells. And I return a spell by name. And of course, if a name does not exist, I should not simply say let the compiler give me an error, let the runtime give me an error saying key does not exist in dictionary, but I should be more precise about it. So I should throw an exception if my spells don't have name. I would like to say spells try get value out var spells spell throw new. Um, won't I need to explicitly specify my spell in the out? I mean, let me try. But I think I'll need to explicitly say what spell is. Okay, that's good. I didn't know that was a thing. Okay, let's create an exception. No spellbook. Spellbook, no spell found exception. Spellbook? Really? Damn it. Exposed. Okay. Yeah. Nice. I didn't know you can do that. Does resharper suggest though if I put the old way? Let's see. Yeah, it's much better. Uh, does resharper suggest me to edit it that way though? Throw exception. Else doesn't. Let's see fast since well, I don't need an else. Return spells name. Okay, is this by C sharp or by resharper or just by Visual Studio? Oh crap. Actually, this is better. Yeah, I think this is even better. Isn't it? Which of the two would you prefer? This is even shorter. Yeah, I would prefer this one. Oh, okay. Point made. I agree. Okay. So now we have a spell book which returns a spell via an indexer, and now we can extract interface. Really cool. Yes. And we can now move our spellbook as such. And when we create a caster, we have a new spellbook semantically nicer. The name parameter list. Which one are you referring to? Slots. Let's say you start with one slot and you take no spells. Line 85. 96, sorry. Name, spellbook, damage spell. Yeah, when you have a spellbook, it's not sure what name it's referring to, right? I guess it could be spellbook's name, which is not true. And here too, I guess. Hit F2 on line 102. Okay. Right. So now I add a spell just for a spell, which is an even more simplified way of doing it. And this needs brackets. As all. Yeah, yep. Point made. So now we have a caster, which has a spell book. Of course, caster, iCaster. Extract, 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 extract. Refactor, extract. Ah, this is gold. Thanks, Decker. Okay. 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 So now we have a caster, and our final example is quite neat. Control R, Control I. Refactor interface, I guess. Right. So now we have a damage spell. We have a spell book. We don't need a spell book. Now we have a caster. Caster. Call it Decker. Caster learns a spell. And var enemy 1 is new enemy 1 with total HP of 10. And our caster blasts the enemy away with a fireball attacking enemy. And it does that twice and enemy dies. Let's go back to enemy fast. So the thing about enemy, let's add a flag. So if HP is under 0, is that is true. True. And if it is dead, and so is that is true, and if it wasn't dead already, it dies basically. Private void die. Hello. What does it do when it dies? It says dead. Okay, so I should of course split all those in different files. Uh, Alright, uh, let's move this to another class, which is console and example. Let's reference this one and I will delete this. I don't need this. Alright. Game core caster. I don't need that. Right. And lastly, run. So simulation, let's create caster example simulation and let's run it. So if I run this, we should see that enemy dies pretty soon. Go to implementation, take damage. Right. Let's invert this for simplicity. Actually, no, let's not. Okay. Else console right line took HP left is HP. So if I run, it will terminate immediately, of course. Simulation. Presentation, console, simulation. This is an old one. Don't really need this at all, actually. Where is it? Simulation. Get away. Okay. If I go here, console. So if I run, what am I missing? Of course, this all comes from the other one. What am I missing? All comes from the other one. I don't want that. I don't want that. Create repository. What is this? Cast repository. I don't want that. Salary calculator is fine. BMI calculator. Okay. So if I run now, I see that first it took 5 damage, then it took 5 more, and since initial HP was 10, after the second hit it died. So we implemented a spellcaster with damage spell, spellbook, and we encapsulated stuff pretty well, and we abstracted away our stuff well. How did we do it? Well, through several things. First off, if we look at the beginning, we have damage spell, which has read-only name, mana, and damage. Description is a combination of name, mana, and note, basically. And our spell can apply damage, and the way it applies damage, it forces target to receive its effect. The string simply returns description of the spell. Enemy is a target, and our enemy has our enemy, by the way, should have private well, he has private set and HP is public because it's an interface, but I actually would like to hide HP away. It's interfaced, oh, so be it. Anyways, take damage is a thing about enemy, because take damage is an abstract way of saying that enemy loses HP. And essentially it also encapsulates an abstract away logic like losing HP, handling being dead, and displaying your status. Die is a black box. It's an abstraction, and all it does is prints to the console that it's dead. Caster can cast and learn spells, is all it can do. So our caster has a spellbook which we abstracted away in an interface, and our spellbook itself, all it is a dictionary which is read-only, which has maximum slots in it, and all it supports is adding and getting stuff out of it. It does not support removing elements from it. That's why it's very useful. Lastly, some exceptions for errors like running out of slots or accessing item which does not exist in the spellbook. And that's about it about abstraction and encapsulation. Thank you for watching.